Hello dear friends. Hello. Am I live? Are you able to listen me? Hello dear friends. Welcome to Net Classes CS and Paper 1. Dear friends, myself is Jyoti Kumari Chaube and I am going to teach you TOC. Okay, TOC. We are starting here TOC. Now our recent subject is Theory of Computation in easiest way and simple language with me. Okay, very easy language and simple language. Easy way and simple language. Theory of computation. What is theory of computation? Please join everyone. Let me know. Am I audible, visible? Come to the. These are the previous slides. We will start after okay. DFA we have learned DFA. What is DFA? Finite acceptor and finite transducer. Finite automata without output is finite acceptor and finite transducer finite automata with output. Okay, Mille Murray are coming in this and DFA and NFA are without output. Okay, now come to next slide. This is the machine automata, how we are designing automata, final state, non-final state, transition, etc. Okay, एंड दिस इज ट्रांजिशन स्टेट Q0 A लेकर Q1 पे जाता है, Q1 A लेकर Q2 पे जाता है, Q2 A लेकर Q3 पे जाता है, Q3 A लेकर Q4 पे जाता है, Q4 A लेकर Q4 पे जाता है. सेल्फ लूप है. ओके, नाउ कम टू द नेक्स्ट. दिस इज ऑल्सो अ लैंग्वेज एंड DFA Q0 Q1 Q2. And this is also a DFA. Okay, dead state. Here we can see that dead state. What is called dead state? Dead state is the state where incoming transition can come, but from this state we cannot reach to any final state or any other state. Okay, this is called dead state. Means after coming here you cannot go anywhere. Okay, Now come to the more DFS. These are the more DFS. These are N mod 5. I have explained all these things in earlier videos. See dear friends, it is very important to practice more and more DFA, NFA and languages, grammars and means conversion. Okay, so these all are very important. I am bringing here some important examples only, but for practice you have to join my membership, okay, on YouTube. On YouTube there is a membership option. If 2 or 3 or 5 students are ready to join the membership, then contact with me, and after that I will suggest you from where to start membership, and then we will do practice also, because in concept videos it is not sufficient. These examples are not sufficient to clear your means to go deeper in your concepts. Okay, to go deeper in your concepts you have to practice more and more NFA, DFA, languages, grammars and conversions, so many things. Okay, so if you need, then we will manage a membership for 1 or 2 months, and charges are very minimal, 59, 119 and 199. I will start from 59, but these are minimal. Okay, these are minimal, and you can take the membership. Okay, now come to the next topic. Hello sir, Manoranjan sir, welcome. Now here is NFA. NFA means with ambiguity is NFA. NFA we have learned these all things in earlier lectures. Now here each language with which is accepted by a DFA can accepted by NFA. Okay, now I am checking any more point I have added here. Okay, here you can see that there are some points added. Okay, from previous slide I am adding something here. For each computation all is consumed and the automata is in a non-final state. If an NFA is accepting a string, it means there is a computation of the NFA. The input cannot be consumed. It is also done. Okay, these all are alphabet A. We are trying to accept alphabet A, but this is not a final state. That's why it is rejected. Okay, it is rejected. And alphabet, there are, this is another choice here also. This is the same slide, I think, same image. Okay, now come to types of grammars. Wait, I will explain something else, then I will go to the. There is no need to show all the transitions since it is NFA. No need to complete it. Okay, this is very important point. There is no need to show all the transitions. This will make the difference between NFA and DFA. Okay, design a NFA over A and B, and so that every string which accepted which start with AB. Okay, first question is AB. So here we can see that if we are starting any NFA, non-deterministic finite automata, Here is no rule for all the transitions. Now what we will do? Q0. From Q0 we are starting. This is initial state. And Q0 take A to Q1. And Q1 take B to Q2. Okay. So we can say that if here is any string which A B B, okay, if this string is here, then will it pass through the automata? Yes, because A, we are passing one by one. Okay, A is clear. Okay, this is complete. Then B, this is complete. Then A, okay, A self loop is here, you can see. Then B is also here. Okay, you can assume here comma. Okay, so B is also here. And as we want that many chances for A and B from self loop, we can do. Okay, so this is a machine to accept those strings which are starting from A and B. You can see that here A, B. After A, B, anything, A, how many A, how many B, how many A and B's you want, you can add. Okay, but starting with A and B. If any alphabet, if any string is not starting from AB, then what will happen? Okay, I am cleaning this. Okay, now if any string which is not starting with AB, then this will start with B, A, B, A, B, A. Okay, if this string we want to pass through this automata, then what will happen? B, is there any B? No, string is rejected. Now come to the next string. If there is A, B, B, this is a string which is not started with AB, then what will happen? A, Q0 take A and come to Q1, but on Q1 this is stuck, this become rejected because here is A and there is no transition of A from Q1 to any state. Okay, so this will also rejected. Now can you understand how we are passing the strings through the automata? This is the way. Okay, and one important thing, these all slides are very important, dear friends. Minimal string, we will check from minimal string. According to this, what will be minimal string? BA will be the minimal string, and after we can add so many things. Okay, this end with BA. Okay, now you can see that the difference between both the automata. Okay, here this is the final state and it is starting with AB, but in second question you can see that this is final state but it is end with BA, and the self loop come in first initial state. Okay, here you can see that any number of AB and A. So here is BA. So this will reach to final state. And AB, how many AB, this is not the matter. Because in initial state there is a self loop and it will give you all the transitions. Okay, the self loop of a comma b will give you all the transitions from AB, but to reach the final state you have must be two transition BA in sequence. Okay, so after so many ABs, Q0 bring B to Q1 and Q1 take A to Q2 and Q2 is, or you can say that QF is the final state. So string become accepted. But if any transition is absent here, let it be this string, then what will happen? AB. Okay, but in last this is AA. How can we go to AA? A is here, first A is here. Okay, means one, last A we will check here, no A is coming in this. Okay, after self loop there must be a B. Okay, and if we go through B, then what will happen? There are no two A's. Okay, only one A is here before final state, and there is no self loop in final state. That's why the string must have BA at the end of the string. Is it clear? Now check another NFA. I am bringing here very minimal NFAs. Okay, but we have to practice much and more NFAs, and I will try to complete all the concepts within 2 or 3 days, and after that we will I will make slides for practice, and if you are interested then you can take membership for, but when I will confirm you, then you have to take. Okay, because 1 month only TOC practice is not required. So that what we will do, after 2 or 3 subjects I will announce to take the membership of 59 rupees, and you can take the membership of 59 rupees, and we will practice 2 to 3 subject, all PYQs. Okay, within 1 month. In 1 month, if we will complete at least 3 subject practice, then it is good for us. Okay, now come to the next NFA, that contain a substring BAB. Okay, so come here. Here is a self loop. There is no problem in starting, and contain a substring BAB. I am taking different type of NFAs here. This is starting with, this is ending with, and this is containing. Means neither starting nor ending condition is here. Only the string should contain BAB in between, anywhere. Okay, anywhere. So we are making the initial state with self loop, and after transiting B from Q0 to Q1 and A from Q1 to Q2 and B from Q2 to Q3, and after making Q3 final state, we are adding a self loop also here. Okay, and because of self loop, here we can take, at end we can take any number of A and B's, and in starting we can also take any number of A and B's. Okay, now come to C. And again see here, the possible string will be A plus B ka star, BAB and A plus B ka star. This will be the possible string, because star, why star? Because with self loop there is epsilon is also accepted. Okay, epsilon is also accepted on the self loop. Okay dear friends, that's why here is star, otherwise it will plus sign, but star, ni star, as we have discussed earlier. Okay, now come to the next NFA. Design a NFA for the set of all string which start with B, B, A, B. Okay, now you can see that B, B, A, B, this is starting, so we will not make the initial state self loop. Okay, and after starting with B, B, A, B, final state QF, we will make it final state and also add a self loop of A and B transition. That's why all the string started with B, B, A, B will accepted here. Is it clear? Manoranjan sir, please tell me. Okay, now these are the here is one more point I have added here. For all, okay, for all, this is for all sign. For all regular language, if DFA is possible, then NFA is also possible. Okay, now come to next. We have discussed set of rejection. You can also see the one more point I have added here. For each computation, all the input is consumed and all the automata is in a non-final state. Okay, for each computation, all the NFA rejects. Why NFA is rejecting? Because for all the input is consumed and the automata is in a non-final state. After consuming all the inputs, if automata is in non-final state, then it will become rejected, because we need to reach the final state. Okay, the input cannot be consumed. It may possible the input is not consumed, then there is no question to reach the final state. As the input is also not consumed by the automata, then how can it reach to final state? Okay, so for the input is consumed and the automata is in a non-final state, then it will also get rejected. The input cannot be consumed, then also it will be rejected. And if there is no computation of the NFA that accepts the string, it is also rejected. Okay, and in NFA, this is quality of NFA only, not rejection. If NFA all transition move parallelly to, if not, in NFA all transition move parallelly to use multi-threading. Remember it, it is also an important point. The point I am repeating, the point I am highlighting, that it is important. So please dear friends, take it, note down in your notebook and do revise it. Okay, every day. Lambda transition. What is lambda transition? There are some rules in which epsilon, we can say that epsilon move also. Okay, epsilon or lambda. Okay, so there are some condition where Q1 to Q2 or any two state, between any two state, there is a lambda transition. And because of lambda transition, what happened, that the Q1 reached to Q2 without any transition, because epsilon or lambda. Okay, epsilon or lambda is null, just it is null. So if lambda is in between any two states, then this transition will called epsilon and lambda transition, and the Q1, the string which is in Q1 state will reach to Q2, and in NFA only lambda transition is there. So here it may possible that the after lambda transition, the state which is connected with so many states, and that state is not connected with before transition state, before lambda transition state. Okay, here you can see that Q1 is not connected with this much states, but if we will jump to this state, then it will become connected to so many states, so many transitions. It may possible that after this state I don't need any changes, I don't require any more transition. In that case, lambda and epsilon transition is very much helpful. Do you understand? Now come to, it may appear in almost all kinds of NFA in the formal language theory. Okay, this is the note that it may appear in all kind of NFAs. Okay, now dead state. We have seen that in previous slide. Here is a dead state. Where is a dead state? I have shown you dead state somewhere. Yes, dead state. Here is dead state. Okay, you can see that. Just like that, I am explain this NFA. You can see that Q0 is initial state, and ये Q0 जो है वो 0 लेके कहाँ जा रहा है? फाइनल स्टेट पे जा रहा है. ओके, और